the amount of traffic inside that data center is growing exponentially. Second, when we create these large distributed computing systems, the broadcast, the collecting, the reducing, all of those primitives necessary to do distributed computing is causing an enormous amount of traffic inside. So it turns out, in the future, the way you design a data center is going to change. Instead of a whole bunch of compute nodes that are connected essentially by networking, the networking and the compute will become one continuous computing fabric. The network is going to become really, really important. And that's one of the reasons why recently we announced that we're acquiring Mellanox. And let me do this. Let's introduce the CEO of Mellanox, Eyal Waldman, please. Ladies and gentlemen, a visionary, a giant in the industry, and pretty big guy.
Thank you for the introduction, Jensen. Great being
here. Eyal, you know, we've been working together for some time.
Yep.
And we've been working on supercomputers for some time. In fact, I think we've been working on it for about a dozen years. You've been working on it for almost 20 years.
Yes.
And so we've been building supercomputers together. And what are the trends that you're seeing in the world of high-performance computing?
Right. So I think, like Jensen said, we're seeing a great growth in data, an exponential growth, and we also are starting to see that the old program of program-centric data center is changing into data-centric data center, which basically means the data will flow and create the program. Instead of us creating a program using the data will start creating the program using the data itself. And this is things we can work on and actually have very synergistic architecture solutions for the future for the data center.
Mm-hmm. And so, you know, if you take a look at our journey together, we started in supercomputing, and almost all the major supercomputers we worked on, you guys worked on as well, and our engineers worked close hand in hand. And the reason for that is because, you know, when you have all these different compute nodes working together, the synchronization of the information, the sharing of the information into one large simulation is very intensive. Right. But we're seeing the same thing happening now in hyperscale data centers, and we're seeing the same thing happening in enterprises. And what are you guys seeing, and what are the dynamics that's causing that, you think?
Right. So I think if you look at the big hyperscale, one of their big advantage is the compute engine, the supercomputer they have in the data centers worldwide to serve hundreds of millions of people simultaneously. What we help is actually connect the compute to compute and then compute to storage in the most efficient way with the lowest latency and highest scalability. And this is why we increase the productivity, the efficiency of those data centers significantly. Some of the things you showed here is that latency is one of the most important parameters in terms of scalability and then efficiency and productivity, and that's what we do best. We have the lowest latency interconnect on the planet, both on InfiniBand and Ethernet, and we're just improving this now with 200 HDR InfiniBand and also 200 and 400 gigabit Ethernet that we'll continue to develop and have more synergistic products in the future. Yeah, so between the NIC, the switch, the latency of your system is just really incredible. The other thing that you were well ahead at the time was the concept of CPU offload and RDMA, and we also felt the same way. Of course, we didn't call it CPU offload, we call it acceleration. But in a way, you were a network accelerating company all along. Right. So we found out that, you know, doing programs is great by the CPU, but then doing very tedious I/O operations by the CPU is very not efficient. So we took this task on Mellanox, and we do it mainly on the endpoints, on the NIC and HCA with InfiniBand. Then what we found out is we can put computing inside the switch, and this is something we've done with NVIDIA Sharp 2. Actually, to accelerate, we have like an AI offload machine, floating point machines inside the switch to increase the efficiency of artificial intelligence programs in the data center. This is something we're working together. I think you have very recent results. I don't know if you've shown this recently, but we are seeing more and more offload we can take away from the CPU and GPU into the network and then synergize this into the whole data center solution for AI. Yeah, and that's our path forward, to find a way beyond the time when CPU scaling is going to continue to progress. Now that it's slowed down, we have to take as much workload as we can
And of course, moving it into an accelerator is one thing, but moving it into a network is a completely another thing, and we should do both.
Right, and
So,
we will execute on that.
fantastic.
Thank you.
Thank you,
for
Eyal.
being on
Thank
stage
you.
here.
Thank you, Eyal. Ladies and gentlemen, Eyal Waldman.